All right. Good morning, everybody. Thanks for joining us today. Today, we are going to be going over pulse production, agronomy, and research with Mark from Saskatchewan Pulse Growers. And then myself and Charlotte are going to be going over our pea and lentil varieties that we have in the Alliance Seed and CANTERRA Seeds portfolio. We will get started with Mark. You can go ahead and take it away. If you have any questions, throw them in the chat and we will get those answered throughout.
Perfect. Yeah, thank you. So, good morning, everyone. I'm Mark Zatylny, an agronomy manager with Saskatchewan Pulse Growers. I've been here just over a year, and I primarily handle peas, faba beans, and soybeans. I also oversee the root rot task force, where I coordinate research activities with the folks in Alberta and Manitoba. I also facilitate our involvement in the minor use program, where we work to do things such as label expansions to get more products available to growers in pulse crops, as well as I also manage the Applied Research and Demonstration Program, which is our small plot projects that we conduct with the 8 sites across Saskatchewan. And I'll kind of touch on various aspects of all of these different roles as we go along this morning. So just for an overview of what we're going to be talking about, so I'm going to do a quick 2025 pulse crop review of kind of what happened to the growers in this past season, do a little bit on pulse agronomy just to give everybody kind of a refresher on kind of how growers out there are managing their pulse crops. Then I'll dive into our root rot complex and all the various research that we are working on to really kind of get that issue managed better by growers. And then I always have to do a little plug for the ARD projects because that is one of my main areas of focus. So for the 2025 season, so lentils continue to dominate our pulse acres, averaging roughly 3.5 million acres. And then peas are coming in at about 1.7 to 2 million. We did see a lot of pressure on those pea acres with market issues the past little while, but hopefully that tariff agreement that we made with China last week, where we were able to get that tariff dropped on peas, that it will ease that market accessibility issue. For the minor pulse crops, chickpeas continue to increase over the past few years with pretty decent prices and producers looking for an option in areas where they're dealing with Aphanomyces. 2024 was the first time that we've been over 500,000 acres in these minor crops since 2019. And so in 2025, we even broke 600,000 acres. Production has been steadily increasing since the drought we had in 2021, which really held back a lot of those acres. And this year, the yields are sounding like in some areas they are the highest that producers have seen in quite a few areas. Um, but that is very kind of dependent on the weather that everybody experienced. Peas are around 1.6 million metric tons, and lentils are around 2.5 million metric tons. Again, minor crop production. We see that chickpeas are still leading the way. We don't have any 2025 data yet for dry beans or faba beans, but historically, that'll kind of add another 40 to 50,000 metric tons of production. So it should put us up around that 400,000 million, no, 400,000 metric tons on the minor crop production. As for the weather, so at seeding, most of the province had really good soil moisture in April and early May, and soils warmed up really quick this spring because it was kind of not a lot of moisture, a lot of temperature increases. We had a very hot start to the season, but going into seeding itself, everything was pretty much kind of set up for success there with enough moisture in the soil to keep the emergence up. As we started to move into that early vegetative growth, it continued to be those warmer than average temperatures through the middle of May into June, most of the province was recording max temps above 26 degrees Celsius in that first week of June, and a big area in the southwest had above 30 degrees Celsius, with not much additional rainfall. So, kind of at this time is when we started to see the plants becoming a bit more stressed as they had that healthy emergence. There were reports of heat canker in lentils from the south to the north, and one report even from Alberta that was like 700 kilometers north of Edmonton that even was having these heat stress issues. Going into the later vegetative state, a month or so later, we started to get some of that precipitation. It was about 1 to 3 inches across the province. Southeast saw a little bit more, but really the bulk was starting to be a bit stressed by these moisture limitations and that previous high temperatures that dried everything out. And I know down in the southwest, there were several states of emergency that were declared due to the drought conditions. As we move towards the end of July and get into those reproductive stages, some of the earlier seeded crops that were in those dry pockets in the southwest, northwest, central-ish started to see their yields being impacted by that delay in the rain. And then the later seeded crops were able to benefit from the rain that we saw kind of towards the end of July into August. I know we got I think some areas in the southwest got like 4 inches on August 4th. So then kind of the temperatures decreased and the moisture started to increase. Moving into harvest, this is where we really started to see those cooler, wetter weather conditions coming in. And that was really starting to kind of impact the maturity of a lot of crops. Also, with that high moisture, we were seeing that specifically in like peas, lentils, and chickpeas, they were starting to sprout again, even though technically they were ready for harvest before these rains started. So that started to impact the quality. There was a few instances of bleaching in green peas and green lentils due to this moisture. We also had some areas that were hit by really early frosts, and so that damaged a multitude of the crops, such as like the peas and the chickpeas down south. So that was kind of a review of 2025. I feel like I kind of said it pretty doom and gloom, but at the end of the day, most of the province did have really successful yields. The quality wasn't too negatively impacted. We were kind of in the middle range, middle to high for most producers. So it was overall a successful season, just very variable depending on your location. So now I'm going to kind of get into just quick little refreshers. So with pulse crops in Saskatchewan, herbicide-resistant weeds is really one of the biggest issues outside of root rot, because we do have herbicide-resistant kochia. That pretty much all kochia in Saskatchewan is resistant to group 2 herbicides. And then we have populations that are resistant to glyphosate, dicamba, fluroxypyr. Down in the west central area, there is a sulfonaphacil resistant. So that is an issue that growers are dealing with. We had quite heavy pea leaf weevil feeding that even impact the faba beans this past year. So that's an issue to watch out for. This past season, root rots came in much later at the end of the season. It was all kind of looking pretty good because the crops had such a good, vigorous start when there was moisture. And then with all the dryness, there wasn't a lot of opportunity for them to be infected until then that moisture came late in the season that we started to see those issues. And the chickpea health issue wasn't particularly aggressive this past year. There was the occasional site that you would see it in, but just kind of at the very tips of the leaves and nothing that really impacted yield or anything. Here, I'm just showing kind of all the different herbicides we have per pre-seed and post-emergence for our pulse crops. These fact sheets are available on the saskpulse.com website, as this will be kind of hard to read, and we update these every year and kind of want people to use them more as a quick reference for options instead of having to go through like the entire crop protection guide. This is just a quick pulse specific that you can glance at. If we went through all of those sheets, we do see that we have groups 3, 4, 5, 6, 9, 14, and 15 with registered products for fall, spring, pre-seed, in-crop, and pre-harvest. So we do have a decent amount of groups that can be utilized on pulse crops, especially with our big fight against kochia. But unfortunately, also with that, we continue to add groups that it is becoming resistant to, as you can see here with the 249 and 14. Continuing to speak about kochia, here's the latest map from November from the AFC. So this is where they are tracking group 14 resistance across the prairies. And you can really see that it runs from Alberta to Manitoba and from the border up to north of Saskatoon. So it does continue to spread, especially as we know that kochia likes to just tumbleweed away, spreading all those resistant seeds. Some of the top tips we have for this management of this issue. So you really want to spray a herbicide on kochia when they're small, use lots of water to get a lot of good coverage, and make sure that they are actively growing and not in kind of drought conditions that are just kind of stop them there. You do want to again consider those herbicide resistance, trying to use a combination of different modes of actions, including soil residuals to try to impact their growth. And the one key thing also about kochia is it is not particularly competitive. So if you have a really vigorous crop, it will outcompete kochia and can really cut back on the herbicides that you would have to use. Insects obviously impact pulses as well. So we've got the pea leaf weevil is kind of one that was a hot topic this past season. And with it, so we kind of got a lot of calls about the adults feeding on the leaves and you get that notching. That is typically not a big issue. Most pulse crops will grow through that very finely. But what it shows is that those adults have most likely already laid their eggs, and the larvae are the real impactor for yield on pulse crops because those larvae feed on the nodules underground on the roots. And that's really what is hurting your yield potential. Obviously, there's also wireworms that impact all crops pretty much. Cutworms is very similar to how they impact crops such as canola. It can be patchy. You want to spray it at night when they come up to feed. But depending on your pulse crop, they can typically overcome that, such as peas can regrow from the seed and scale nodes, depending on where they were kind of cut off by the cutworms. Aphids blew into the province pretty late in the season last year, but they can very quickly go from low numbers to way over threshold. We were seeing like single sweeps of a plant that had hundreds and hundreds of aphids in it. We also have pyrethroid insensitivity coming in, and this is kind of an issue that we continue to investigate. In that little chart on the bottom right there, if there was no insensitivity to this insecticide, then there wouldn't be any of those bars. But you can clearly see that there are a lot of those bars at a lot of the sites. So that is showing that that insensitivity is spreading. And then grasshoppers are always kind of a hit or miss. There seemed to be a lot last year, but they weren't really impactful. The next one, of course, is diseases. So root rot obviously is the biggest challenge. There are seed treatments available, but like all seed treatments, they only last for that first 3 to 4 weeks. And the ones that are commercially available are typically just for suppression. Ascochyta is the most serious disease in chickpeas, and we are doing a lot of work on resistance through breeding programs for that one. White mold kind of shows up when the crop canopy closes. It's lush, it's very healthy, but it's holding on to that humidity and moisture, making a mold easier to grow. But there are management methods for that. And then some of these other diseases that I've listed here, they're very much just like intermittent depending on the year, not necessarily an issue every year, not every field, not every pulse crop, just kind of come and go. And then lastly for this is the harvest and storage considerations. So one of the key things we always want growers to know is to understand the difference between a desiccant and a harvest aid. So desiccants are used to actually kill the crop, such as dicot, whereas like glyphosate is a harvest aid that kills the weeds and kind of makes it easier to harvest, but isn't a true desiccant. And you always want to apply these at 30% seed moisture or less. Lots of products though, and always kind of follow the label. And we really want to be careful with the MRLs that are applied to pulse crops, as majority, I think it's 85% or something that are grown in Saskatchewan are exported. And so you really want to know the MRLs of what you're applying to make sure that it will be bought by whoever is purchasing it and the end user. So that is really a thing to watch out for. And the keepitclean.ca website is really a beneficial tool to make sure that you're kind of keeping up to date on how other countries are looking at our crops. So now let's get into the fun part. So root rot complex, as we know, I'll be saying the word complex a lot in the next few slides, and we'll just explain it as best as I can, but it is a very large topic and definitely the most impactful issue that growers in Saskatchewan are dealing with when growing the various pulse crops that we have varieties for here. So with this image, we know pea and lentil, those are the most susceptible we have. And then kind of as we move down the line here to Aphanomyces in particular, we go to dry beans. These ones are very dependent on the variety, as some have more resistance than others. Fava beans, with most recent work that's coming out of the University of Saskatchewan, is showing that certain isolates of Aphanomyces can be negatively impacting faba beans, but that's another one that is also variety specific. Chickpeas are typically grown in those drier south areas. They do show partial resistance, but when you run a test on the roots, you can detect Aphanomyces. It just doesn't seem to really negatively impact the plant. So there are kind of some research being done, but there is partial resistance there. Fenugreek, we're not super sure about just yet, but the research is showing that it is a non-host, and we know soybeans and lupins are also non-host crops for Aphanomyces. Just a quick overview of Aphanomyces to make sure we're all on the same page. So we know that this pathogen is very long-lived in the soil. It can easily do 10 plus years. It really needs that moisture to be able to kind of run its life process and infect the host crops, and then continue to build up that pathogen in the soil. It does build up over time. I often kind of consider it similar to clubroot in canola. Very different life cycles, very different requirements, but kind of how it can stay in the soil and transfer with the soil and needs specific conditions to impact the crop. And right now, as you'll see, lots of work is going into the research on this to try to find a better method of dealing with it than just kind of focusing on rotation, which at this stage is still kind of 6 to 8 years between host pulse crops. The other one I'll be talking a lot about is fusarium. So this one is very common in a wide range of not just pulse crops, but very many other ones in the cereals and the oil seeds. Uh, Pulses are particularly susceptible to it, though, so that kind of when they're in your rotation, they can be very susceptible to being infected. And as I'll talk about with using the word complex for all the root rots, fusarium itself is also a complex, as there's over 80 different species within that group. And they all kind of interact with each other and infect crops differently. So getting into some of the work that SPG is doing. So here is kind of research that is going into the pathogens themselves. So primarily Aphanomyces, but also that fusarium. And lots of money is going into this, and lots of different researchers from around the world are involved in these projects. Here you can see the various different pathogens that are in this complex that we're researching. So there's the Aphanomyces, Fusarium, Pythium, Rhizotonia. Honorable mention goes to Botrytis and Sclerotinia because sometimes they show up, sometimes they don't. And all of these are kind of, they work together, they fight each other. One can infect the root first, and then like typically Fusarium would, and then Aphanomyces can come in after. So it's a whole complicated situation in that root sphere. The three major ones that we deal with in Saskatchewan are the Aphanomyces and two different Fusarium species. And here you can just see the various prevalence percentages that we've seen over the last 10 years of testing and scouting these fields for the peas and lentils. And as I've been saying with the word complex, so here is showing that those fusarium species, when you're like, oh, Fusarium solani, that's the one that's impacting my crop, it actually itself is a complex as well in the complex of root rots in general. And that's one of the reasons why finding genetic resistance or different management techniques is very complicated because each of these different species reacts differently in their environment and to what they do to the crop and how it all kind of works together. So as I was talking about with Aphanomyces, so one of the biggest problems with working with it is just difficult to actually work with. So it's hard to get out of the soil. It's hard to work with in the lab. It's hard to work with in greenhouses. So we're constantly having to develop and refine new protocols that allow consistent testing of the pathogen. We've been working on it for 10 plus years. So it's like in the long scheme of agriculture, it's a very new issue that we're dealing with. But that's kind of really showing all the investment we're doing to make sure that we can find some kind of method to really enable producers to keep pulses in their rotation and not be devastated by Aphanomyces. Some of the other things that we're looking at, not just for like genetic resistance, we're looking at different biological products. There's some research going into certain microbes that you can apply to your seed that kind of are antagonistic to Aphanomyces in the soil, various different chemicals that we're looking at. Um, RNAi technology is a big one, but that is requiring a lot of um, financial input and very technical research. And then obviously, kind of the IPM of all of it with root rots in general is getting that post resistance, plus maybe a biological or a chemical control options. Lots of different combinations of stuff to make sure that growers can manage having Aphanomyces in their field. This one I just kind of wanted to show is one of the projects that we're working on and just really demonstrates how the pathogen can survive in the soil. So if you kind of look at the charts on the right, where when the soil is dry, then kind of things stay pretty even or decrease. But when you get that moisture, that's really then where that inoculum can build up in the soil because it needs that moisture to be able to do its role. And so really that's kind of one of the big key takeaways and why we see Aphanomyces so variable through every growing season is because of how much moisture is, where the moisture is, and when it is in the field during the growing season. Because Aphanomyces can infect the crop from seeding to harvest, basically, it just will change how impactful it is and the damage it'll do to the yield. Next, we'll go into the host research. So this is looking at the various different pulse crops and how they are impacted by root rots. You can see here there's been a lot of money gone into this as well. And this one is a very complicated process. As soon as you get into the genetics and breeding, a little above all of my knowledge, but I'll try to explain it as best as I can. One of the key things is, as I was saying, Aphanomyces is hard to work with. So it's also difficult when you have Aphanomyces out in the field to actually be able to dig up those roots, get really valuable data from it. Takes a lot of time, takes a lot of manpower. The it's a whole situation in of itself. And so we do have a lot of work going on into developing these various tools that hopefully can shorten the amount of time and effort to get these various aspects of genetic research done. So for example, here we have the genomic tools. So this is really looking at markers to ID genes, where in the lab you can then quickly start to cut out which varieties are not going to have resistance and which ones will. Phenomic tools is all about how it looks. So we're looking at if we can see visible symptoms above ground earlier, that we can kind of cut those out of the breeding program. Root evaluations in the lab and greenhouses, and testing that germplasm quicker. Predictive breeding. So this was a project that was announced last week at our AGM. And what it basically is taking a mass amount of data from the genomic and the phenomic into a database where we then can create a model that will predict the best crosses for the breeders to utilize to really ramp up what genes we think are valuable for resistance to Aphanomyces. Because we really want to get traits out to growers as fast as possible to really combat this issue. Majority of the work is going to Aphanomyces right now, but there is some with the Fusarium species as well. And here you can really just kind of see the importance of having those various tools to help identify kind of this needle in the haystack of genetics for resistance to Aphanomyces. So using this chart right here, it shows that there's 4% of the lines tested have partial resistance in this project. By doing this, readers can then cut out the 96% of the other material that clearly shows no resistance or is susceptible to Aphanomyces. So instead of looking at the 100%, we're already down to just looking at 4% to produce seed, speeding up breeding and all the other testing that comes along with that. And in reality, this kind of removes about 2 years worth of work to get the material to growers quicker. Another one is kind of with the peas and lentils themselves, just kind of giving you an example of the different work that's going on. One of the things with all of these genetic breeding, researching projects, and we've seen it in canola a lot, is whenever you kind of add resistance or a trait to the crop, it typically then will hurt yield. There's kind of a cost of having that resistance. So we're doing a lot of work to make sure that the crop has the resistance, but also is still yielding like other commercial varieties that are currently available. And then another one with this is just there's just like tons of side projects that are always going on. So again, looking at are there susceptibility genes? So if we don't just get resistance, is there something in the crop that is allowing it to be infected easier? We know there are possible aspects of the seed coat coloring that may deter infection at those early stages. There's some work on the root architecture and then gene editing. Lots of various, we're kind of coming at this issue from all sides with uh, in relation to the crop itself. Some of kind of the key takeaways from all of this for an actual grower that can utilize today. Really, we've seen if you have excellent seeding conditions, a super vigorous variety, it just is a more robust plant. It will be better able to combat an early season infection. So the healthier, happier your crop is, the less likely it is to get infected, even if conditions are suitable for infection. Seeding date, also important because Aphanomyces likes those warmer temperatures, but you don't want to go too early where then your seed is just hanging out in the soil too long, because that can be another issue as well. Seed treatments are important. We know it is just suppression of Aphanomyces and helps with those other root rots, but it is just focusing on that early season infection, which also is going to be most damaging to yield. And then seeding depth, that kind of ties into it again, just getting that crop out of the ground quicker and more healthy. And then rotation, knowing the risk of what you might be seeing and experiencing out in a field. Here is just an example of why rotation matters so much. So the field on the left is a 4-year rotation from the last time peas were grown on it. And you can see quite a lot of damage from Aphanomyces that is not going to yield very well. While on the right, that is an 8-year rotation from peas, and it looks drastically different. And everything else was the same between these fields, other than that rotation timing. And then I just want to quickly go over a couple of these, because as I was saying, Aphanomyces and Fusarium and all their intricate parts are the main um, pathogens that growers are worried about, but they're not alone in this little family of pathogens. So here we have Rhizoctonia. This one I'm sure most of you have run into a lot. It's very similar and just kind of hard to distinguish from Fusarium later in the season. You get these same lesions. It likes that warm temperatures to really be aggressive, but just another one to look out for. Pythium, as I was talking about, this one has a wide host range, likes it a little bit wetter, whereas a little bit cooler. But it, yeah, again, just can negatively impact the various pulse crops. And another one is Phytophthora. So this one is um, um, it's very similar to Aphanomyces in its life cycle, but it primarily only impacts soybeans. So for those growers, kind of down south primarily, that are growing soybeans, Phytophthora can be one of the main diseases that they would want to look out for. And because soybeans are not a host crop for Aphanomyces, this is like the analogous pathogen to that. Okay, so that was a lot of talk of what is hurting our pulse crops, and all the work that we're doing to try to remedy that. Now just kind of real world scouting and prevention options for growers out there. So here's just a list of various seed and soil-borne diseases for the various pulse crops, economic thresholds, using seed treatments, what can be seed-borne that can be impacted by that. It's just a nice quick snapshot of what a grower can really utilize. The big thing is always to scout early and scout often. As I was talking, a lot of these pathogens can impact from just before even crop emergence when the seed is just starting to get going, and then all the way up until flowering later in the season. They really can run the full gamut of crop development when they're infecting. The root rot, typically, if you're using a seed treatment, will be after that expires, and then you'll start to see some above ground visual symptoms. As I've been always saying, because it requires moisture to be able to infect the pulse crop, low spots where water runs, all of those are kind of the key areas to look at. Compacted soil would be the second area that you have a higher risk of being infected. And just getting out there, digging up the roots, looking at the plants, seeing how the nodulation is doing, all of that is it's not one of those diseases early in the season you can just drive down the road and be like, oh, I spot it. You really do have to get out there and look at the crop. And then thankfully, there are a ton of the labs now that are doing either soil testing or root testing. So you can kind of get a better idea of what you're dealing with out in the field. Ways to mitigate this, again, it's that crop rotation of typically 6 to 8 years between pulse crops, using those seed treatments. Don't roll your pulses when the soil is wet because this increases compaction as well as spreading around that potentially infected soil to other areas of either that field or your other fields that you go to. That water management, again, just keeping water low because that reduces the risk, as well as you want to have a really good herbicide management program because volunteers and certain weeds can also be hosts to these various root rots. And really just making sure that you have the best possible start and healthy crop to combat any potential for infection. And the other thing that can be useful in your planning, so it's the Aphanomyces Risk Evaluation app or the AREA app. You can access this through both our website, saskpulse.com, as well as if you just Google like Aphanomyces Risk app or kind of any combination of those words. It's typically the first one to come up. And it uses historical satellite data as well as crop rotation to determine kind of if you plant a specific pulse that's a host the following year, um, kind of what the risk is of it being affected. This is updated every year, um, and it is a very valuable thing to just kind of check what you and it could be anticipated to see in the coming season. And lastly, just my plug for the applied research and demonstration projects that I work on. So this past season, we had 7 that were going on. 2 have just completed. We have 5 of those that will then be continuing into 2026 growing season, plus 5 to 7 new projects that will also be in that program in 2026, looking at various things for peas, lentils, faba beans, fenugreek. We're always open to ideas of what growers want, and all of this data is posted on our website so that it is readily available. I'm sure if anybody ever goes to the AgriArm field days and stuff, you'll see a lot of these. I know in 2026, there will be more pulses that are shown at those field days. So a lot of these different projects will be um, readily available to look at and talk about. And yeah, with that, so there's my contact information. Mike Brown is the other agronomy manager that deals with the lentils, chickpeas, and dry beans. So you can contact us however you want. We are always open to questions and comments, helping growers do what they want to do and teaching agronomists so that they can teach their growers as well. Yeah, that's that.
Awesome. Thanks, Mark. If there's any questions, please put them in the chat. I do have one quick question for you, and maybe you're unsure, but is there a Aphanomyces risk app in only Saskatchewan, or is there one for Alberta and Manitoba as well?
So the one that I showed, that is only for Saskatchewan.
Okay.
And no, and I don't even, I know Alberta for sure doesn't have one because we
Okay.
were in talks this earlier this season about kind of how we can transfer that knowledge to their team
Yeah,
so that it's more accessible.
for sure. Awesome. So there is a question here. What is the better form of inoculant, dry or seed applied, or both on peas?
So that kind of depends. Um, so if you haven't grown peas for a long time, then typically I do like double inoculant. But if you are regularly growing peas, like every 6 years or kind of in rotation, then typically one would be enough. Um, as for which one is better, I think it kind of depends on your setup in your farming operation. Like I know the granular one is typically easier to apply just because growers are set up for that. But if you're doing your own seed treatment on the peas, then topping it up with a liquid inoculant could probably be just as easy for you. That one you just want to make sure because the inoculant is a living organism, you want the compatibility with your seed treatment to be correct because you don't want your seed treatment to kill your inoculant before it even goes in the ground.
For sure. Awesome. Thank you, Mark. Um, I do not see any. Hold on 1 second. There might be another question here. Okay, there is another question here for pea leaf weevil. Does seed treatment help in reducing damage, or is there anything we can apply foliar?
Yeah, so seed treatment definitely does help because that is when the most damage is happening, is when the what are they called? Larvae are down in the roots. That's when they can be killed off. Foliar typically is almost never used because you can kill the adults all you want, but if you have them there, likely they've already laid eggs, which will then not be impacted by foliar applications. And most pulse crops, really all of them, when they are getting a lot of adult feeding on the leaves, typically, even like you can get a lot of feeding and the crop will be fine. It'll grow through that. It is that larva that is what's hurting yield, not the defoliation by the adults.
Awesome, thank you. Okay, it looks as though there isn't any other questions right now. So we will get started onto our second portion of the webinar. Thank you again, Mark, for joining us. We really appreciate it. That was awesome.
Perfect. Thank you.
Okay, Charlotte, I just need you to, it's not on presentation mode yet. Just a second as we get things switched over here.
Sorry, can you see the presentation yet?
I can, I just need you to go to slideshow and then present because it's still showing at the still showing as a PowerPoint.
Is that working now?
Yep, there we go. Okay, perfect. So I will get started. Yeah, thanks again, Mark. So I am going to be going over our pea varieties, and then Charlotte will be following up on the lentil varieties right after. You can flip to the next slide, please, Charlotte. So as far as the Alliance and CANTERRA portfolio goes, we only have yellow peas in our portfolio. We do have a forage pea coming down the line, but we are a bit of ways away from that. So that will be our focus today. So first up, we have our flagship variety, AAC Carver. This is a very well-known pea variety across Western Canada. It's been very consistent as far as yields go. And it does have that early maturity as well, if that's something you're looking for. And really, we find it suitable for all pea growing areas. It has a good fit everywhere. And it does have a larger seed side, which makes it easier for handling at harvest. Next slide, please. And next up, we have AAC Beyond. So this is the new yellow pea on the CANTERRA side of things. It's also an early maturing pea. Really great yields. Did fantastic in Saskatchewan, which I'll show you shortly. High protein content, and it has that really good disease package with an MR to Fusarium wilt. Next slide, please. And CDC 5791. This one looked fantastic in the Alberta Seed Guide. Very high yield potential, high protein content, and good seed coat breakage. And does have that MR to Fusarium root rot as well. So really strong disease package. Next slide, please. On the Engage side, and sorry, I should have said AAC Beyond is launching this spring, and CDC 5791 is launching soon. Sorry, just to backtrack. So CDC Engage, this variety is going to be launching this coming fall. So it's not quite out yet, but it is our new yellow pea that we have on the Alliance side. It yielded 109% in southern growing regions of Saskatchewan and 107% compared to CDC Amarillo in northern growing regions of Saskatchewan. So good protein content on this variety, low seed coat breakage as well, and good lodging resistance. I had one of my growers in Manitoba said it stood very well for her, even when she was combining, and she did not spray with anything because she is a seed grower. So always really great to hear that feedback. Next slide, please. And on the Alliance side, we also have CDC 5845, Lots of similarities between CDC Engage and CDC 5845. But one thing on the 5845 is that it does have that stronger disease package. So it does have an MR to Fusarium wilt, where Engage has an I. So 104% of checks, and then improved seed coat breakage. So this one will also be launching in the fall of 2026 as well, which is this year. Next slide, please. So we have a lot of things going on P-wise, so I thought it'd be nice to kind of break it down in a agronomic trait summary, depending on what you're looking for, because I truly feel like peas is one of those things where some people want a larger seed size, some people want smaller, maturity, seed coat breakage. There's a lot of different factors that people look at besides yield when it comes to growing peas. So if you're looking for something earlier, Carver and Beyond would be a good fits, but their seed sizes are very different. So Carver has a larger seed size, Beyond has a smaller one. So Carver, the larger seed size will be more handy at harvest, and the smaller seed size will be more handy at seeding. So it really depends on your operation and what you look for. CDC 5791, Engage, and 5845 are all our longer season varieties. Once again, seed size is quite a bit different. So 5791 is a larger seed size. Engage and 5845 have that medium seed size, and all are pretty good on seed coat breakage as well. So there's a lot of different things agronomically if you're looking for in the pea varieties. Next slide, please. So this is out of the Alberta Seed Guide, the 2026 yield data that I pulled up and made a graph just kind of looking at our varieties and how they do compared to each other. So 5791 did extremely well overall, and this is overall in Alberta. So they do actually break it down per soil zone. I highly recommend going to look at your Alberta Seed Guide to see what variety did do best in your soil zone. But for East today, I did do overall. There's a lot of great things going on yield-wise here. Next slide, please. So for Saskatchewan, I did break it down for Saskatchewan South 1, 2, and 3, and Saskatchewan North 3 and 4. CDC Engage did extremely well in the south, and AAC Beyond did extremely well in the north, but all varieties did very well overall. So once again, it really is, what are you looking for in your pea package just besides yield? Is it the maturity? Is it seed coat breakage? Or is it seed size? There's a lot of different things to look at here. Next slide, please. And then in Manitoba, all the varieties were very, very similar to each other. All were kind of 99% of what you'd see with Carver. The nice thing about Manitoba, and I didn't include this as well, just for ease of time, is that it does have the information of how each variety did in each town. So there's Melito on there, there's Holland on there, Swan River, stuff like that. Make sure you look at that data and also talk to your local seed grower. They've been growing these varieties for a few years before they get launched into the market. So they're always a really valuable resource, in my opinion, to get that kind of information from and how well it does in the area for them. So I will hand it over to you, Charlotte. If there's any questions, yeah, I will be monitoring the chat.
All right. Okay, I will take over for lentils now. Sorry. Okay, so we will start with CDC 6928. So these ones are available this year for this growing season. I guess like seed guide data wise, they've done really well, more so I guess like in the north, so area 3 and 4. They're an MR to Assacarda blight, MR to Anthracnose race 1 as well. Seed size wise, you can see there are 36 grams per thousand. So, very similar to the Czech. CDC 6956, so these ones are in pedigreed seed production. Yield very high. They ranked #1 basically for seed guide data in Saskatchewan this year. Also an MR to Assacarda blight, a MR to Anthracnose race 1 as well. They are on the larger side for a small red. So if that's something that you're looking at, they would be a larger option compared to like the CDC 6928, as you saw. So these ones come in at like a 47. So they're like closer to a medium red, but they're still considered a small red. There's also some, good data on them, and they've been looking really good for a yield. CDC 7208. So these ones are also coming soon. Did really well in the south. Um, and they're kind of, a medium size. MR2 Assacided Blight, MR2 Anthracnose Race 1 as well. They're 41, so they're a different seed weight compared to the ones that I just talked about, or the smaller, so they're kind of in the middle of the range, depending on what, seed, what variety you're used to and what you might be replacing. CDC 7358, so this is on the Alliance side, and they're a small green lentil. Um, they're, high yield, so 111% over the small green check, which is CDC invincible. They're IMI tolerant, good disease package as well. So we're excited for these ones to be coming in a few years. Rougeau, another new one on the Alliance side. So focus, they've done really well in areas 1 and 2, so more in the south. They're a taller plant, so feedback so far has been that, that helps obviously with like harvestability and how they stand. So they're, 3 centimeters taller than most like other small reds. So we're excited to see how these ones come out in the next few years with seed growers. And that is all we have. So if you have any questions within your province, here's the three of us for your contacts. And yeah, is there any other questions?
I do not see anything in the chat. We can